negatively affected its own development. We all know that what we call the Milky Way is nothing more than the galaxy that houses our planetary system. In this case, it is a spiral galaxy about 120,000 light-years in diameter. Just to understand what a boundless size we are talking about, 1 light-year is equivalent to about 63,000 times the distance between Earth and the Sun. Its basic structure consists of a stellar component compressed into a disk about 1,500 light-years thick, a disk filled with hundreds of billions of stars, dust, and gas, mostly arranged in irregular spiral arms. Globular clusters surround the disk in a spherical swarm concentrated toward the center of the disk. This swarm of clusters, which also includes some single stars and scattered gas, defines the galactic halo. According to current estimates, the Sun is about 27,000 light-years from the galactic center, occupied, as we shall see, by a giant black hole. The Sun, other stars, gaseous nebulae, and everything else in the galaxy revolves around the galactic center, moved by the gravitational attraction of a large number of stars concentrated there, in the same way that planets revolve around the Sun. Okay, you will say, but we, with our negligible planet, where are we in relation to all this? Where are we located in the Milky Way now? Well, from what we know today, the Sun is located near the inner edge of the so-called Orion Arm, at an estimated distance of 27,000 light-years from the galactic center, and about 50 light-years above the galactic plane. And is this good? For the most part, we have gotten on well with the neighbors, the nearby stars, and the interstellar clouds of gas and dust visible in the night sky. Occasionally, however, some astronomical event has gotten in our face, incidents from which life on Earth has always suffered. It has been proposed, for example, that especially powerful stellar explosions of nearby stars called supernovae may have been responsible for one or more of the mass extinctions that have occurred over the history of the Earth. Despite such astronomical events, complex life manages to flourish here. But different regions of the galaxy have distinctly different features and properties. Could we do so well if the solar system were located elsewhere in the galaxy? Could such a richly diverse, life-supporting world as Earth have developed and survived at the center of the galaxy? Or in the bar of stars, gas, and dust that pierces the center of the galaxy? Or above the spiral arms? Or beyond them? Follow me. Hey, guys, just a moment before we continue. Be sure to join the Insane Curiosity channel. Click on the bell. You will help us to make products of ever higher quality. At the center of our galaxy. We aren't at the center of the galaxy, but could we be? Activity in the center of our galaxy is dominated by a black hole with about 4 million times the mass of our Sun. A black hole is a region where matter has become sufficiently concentrated that its gravitational force literally changes the shape of space so much that matter and most energy that enter it cannot escape. One exception to the rule of nothing escaping is the force of gravity created by the matter and energy inside the black hole, which does extend out into the rest of the universe. This black hole is not an anomaly. Astronomers are discovering that such supermassive black holes, each with between 100,000 and a few billion solar masses, exist in the nuclei of most galaxies. The monumental gravitational attraction of the Milky Way's supermassive black hole is the main arbiter of activity in the galaxy's center. Among the objects we see orbiting it as rapidly as planets orbit, the Sun is a full-fledged star. Plausibly, planets could form around such stars. But would these planets provide stable platforms on which life could evolve? Contrary to the common belief that black holes are giant vacuum cleaners in space that suck everything into them, weird effects only occur within a few radii of these objects. For example, if a black hole is 1,000,000 miles in diameter, then bizarre behavior of space, time, matter, and energy occur only within 10 million miles of the black hole, which is a tiny distance on the scale of a galaxy. Earth, for example, is 93 million miles from the Sun. At the distances that the stars closest to it orbit the Milky Way's supermassive black hole, they only feel a normal gravitational pull from it. Pierce un problema. Unlike the planets in our solar system, which all orbit in essentially one plane around the Sun, the stars orbit in all directions or planes around the galaxy's supermassive black hole. They have very elliptical orbits around that black hole, meaning that throughout their orbits their distances from it vary tremendously. It is not unusual for these stars to be 10 times farther away at the most distant points in their orbit compared to where they are closest to the black hole. The change in distance between the black hole and a star means that the orbits of their planets will also be continually changing due to the changing gravitational attraction of the black hole. Likewise, the other stars in close orbit around the black hole will pull on the planets orbiting neighboring stars. It is therefore unlikely in the extreme that any planets around stars in the nucleus of the galaxy will orbit reliably in the habitable zone of their star. Even planets whose average distance from their star is in the zone would sometimes be in regions that are too hot or too cold for water to remain liquid on their surfaces. Plausibly, a passing star could rip the planet from another star completely out of orbit. Even farther out in the galactic nucleus, beyond where stars are in tight orbits around the black hole, planets will experience effects that are very likely to keep them uninhabitable. All stars in this region would likely be on such chaotic orbits that they would frequently pass close enough to each other to disturb comet clouds surrounding neighboring stars. Each such event would greatly set back, if not stop, the evolution of life on an Earth-like planet, making these worlds unlikely habitats for humanity. In the galaxy's bar, moving a safer distance from the more dire effects of the supermassive black hole in the galaxy's nucleus, we next encounter the bar of stars, gas, and dust. The existence of this bar, suspected since the 1990s, was confirmed in 2005. Its dimensions are roughly 24,000 light-years by 6,000 light-years. The matter in the inner region of the bar flows perpendicular to it, whereas in the outer region of the bar, stars, gas, and dust flow down the bar, turn around at the end, and flow back. Like a propeller, the bar itself also rotates about once every 15 million years. Some of the gas and dust in the bar are apparently channeled down to the supermassive black hole, providing raw material for star formation, as just discussed. Several features of the bar suggest that few life-supporting planets could exist in it. Consider a star and planets that just formed in the bar and are moving down it from one tip to the other. As this system nears the central region, it is likely to encounter stars that are moving across the bar, perpendicular to its motion. As discussed earlier, sufficiently close encounters will change the orbits of planets, taking the potential Earth out of the habitable zone, or at least throw lots of comets toward the planets. These things are likely to occur eventually, even if this doesn't happen on the first 100 passes through the central region of the bar, long before advanced life evolves on the planet. Likewise, things get very hectic at the ends of the bar, where stars and clouds are turning around. A related problem in this inner region of the galaxy is the large quantities of interstellar gas and dust in the bar that are being drawn down toward the black hole, above or beyond the spiral arms. Despite appearances, galaxies like the Milky Way are much more than just disks of stars, gas, and dust with spiral arms. There are things in the galaxy above and below the disk and things that exist far beyond the visible limit of the disk. Most notable among the galaxy's constituents outside the disk are the globular clusters. Containing up to hundreds of thousands of stars that are gravitationally bound together, globular clusters swarm around the disk like mosquitoes in summer. Globular clusters regularly pass through the disk, but they spend most of the time outside of it in what is called the halo of the galaxy. This is a spherical region centered on the supermassive black hole in the nucleus of the galaxy, extending at least twice as far out in all directions as the spiral arms. The halo also has billions of isolated stars that are so dim compared to the light from globular clusters that we do not normally see them. The problem in forming an Earth-like planet outside the disk in which we exist today is finding enough gas and dust concentrated in one place out there to create the sun and planets. Terrestrial planets form almost entirely from the debris of stellar explosions. We know this because the matter in the universe when it first formed was only hydrogen, helium, and lithium. There is very little of any of these elements on Earth compared to iron, silicon, and numerous other elements, all of which are formed by fusion in stars and stellar explosions. A large fraction of the matter ejected when stars explode in the disk of the galaxy remains in the disk, allowing this gas and dust to be recycled into new stars as it passes through the spiral arms. Our solar system must be at least a second-generation system because so much of the Earth's content must have been formed in a previous generation of stars. The thing that prevents Earth-like planets from forming in the halo is that after the first generation of stars formed out there when the universe was young, the gas and dust ejected when these stars exploded did not remain sufficiently concentrated so that another generation of stars could form from it. Even in globular clusters, the gas ejected by exploding stars drifted away. Astronomers, therefore, see very few, if any, new stars forming outside the realm of the spiral arms. In conclusion, based on what we have just said, we can divide our galaxy into three zones: that of the center and central bar, the middle zone of the spiral arms, and the outer arms and halo. With these final considerations: within 13,000 light-years from the center, too close to the galactic center, stars would receive intense X-ray radiation from the supermassive black hole at the center of the galaxy, and it is very unlikely that life could develop in such an environment. The center of the Milky Way is also much denser with stars than the outer regions. Supernova explosions are much more frequent there, and the radiation would sterilize any planet capable of harboring life. The stellar density and fast elliptical motion of stars near the black hole would also lead to continuous gravitational contention. Between 13,000 and 33,000 light-years from the center, this is the habitable zone by definition. Planets have had sufficient heavy elements to form and initiate a biological cycle, as well as a stable and safe environment that allows life to thrive for a long time. Between 33,000 and 50,000 light-years from the center, this region is rich in hydrogen and helium, while there is a very low ratio of heavy elements. Hardly any planets within it will be rocky and therefore suitable for harboring life. More so, the same can be said for the galactic halo, which is almost entirely devoid of stars capable of producing heavy metals. Of course, one cannot fail to notice that our solar system with our Earth is almost exactly in the central part of the habitable zone. A coincidence? Is it really possible for us to have been so lucky? And does this mean perhaps that we should consider our existence almost unique?